Today we are into the next lecture of systems engineering. I am Dr. Deepafil from IIT Kanpur, and we will continue on our discussions on systems engineering with today's topic being life cycle integration. Today's learning objectives include three major things. We will discuss about what is life cycle integration and its importance to systems engineering, and we will also talk about what are the life cycle functions, the rate of them, and we will discuss in detail what are the life cycle functions and some of the systems engineering considerations. It's kind of like a recap of what we actually studied so far. So, a quick recap before we begin. We actually saw this figure and we have been discussing the three aspects of it. We studied what is the development phasing, and we also saw what is the systems engineering process and how the product baselines are created. And now we are going to talk about the two things, which is life cycle integration, which results in life cycle planning, and as well as integrated teaming, the two major aspects of it. We also saw what is this is a systems engineering management, why is it is an important system, and why it is an important aspect of realizing complicated and large projects. So, we will do life cycle integration in today's discussion. So, what is a life cycle integration? It is an integrated development because of what it means is it is a concurrent means simultaneous or together. It is a simultaneous or together consideration of all life cycle needs during the development process. So, when you are doing the development of a system, this development process is the system development process. So, this is the system development process. When you are developing the system, you need to consider all life cycle needs, of the system or the product, whatever it is, concurrently or togetherly. So, you do not design the product and then decide on the life cycle. When you are doing the development phase, along with the same time you concurrently consider the life cycle needs of the product development during this systems engineering process. That is why it is called as an integrated development. It is also known as IPPD. IPPD stands for integrated product and product development. So, the technical term for life cycle integration is IPPD, or the integrated product and product development, where concurrent considerations for all life cycle needs during the development of the system or the product is done. And how is this IPPD is achieved, or how do we realize the integrated development? It is achieved using IPTs. IPT stands for integrated product teams. So, this realization, or when we go back to the previous slide, we were talking about the integrated teaming, this aspect, it and the life cycle planning, both of these are interconnected. In this present discussion, what we said is through IPPD is achieved or realized, IPPD is achieved using integrated product teams. And what is an integrated product team? This is always a big and good question, and to a large extent a systems engineering development, any systems engineering endeavor survives due to the existence of good integrated product teams. So, one of the requirements is realize or have good IPTs. I would probably change this good to excellent IPTs as the right phrase. And what is the characteristics that makes a good IPT? The first characteristic is there should be a balance between product and process development. So, the team should be capable of looking at both product development and as well as the process development. There should be a balance. Certain times what happens is people develop excellent, really good product, but the process is to realize that product does not get developed in that process. So, resulting in which the product development does not really survive very well. Sometimes what happens is the product development becomes shoddy, whereas the process is extremely developed very well. So, that at the end of the day you have a very good process to realize not so good product. So, there should be a balance. This key word is balance. This team should be able to realize a balance between product and process development. And the second part is there should be early involvement of appropriate disciplines. So, if we have been using UAV as an example, so if you think about UAV, we talked about the 5 aspects of the UAV. So, the first one is an airframe, then you have is a propulsion, then you have is a control, then you have communication, and then you have is a payload. So, if you think about these 5 aspects, the airframe, here you would require aerospace engineers, structural engineers, then you would require CAD CAM experts, machinists, manufacturing people, molding experts. So, the interdisciplinary team or the IPT that will be taking charge of the airframe will be one interdisciplinary team. There will be a propulsion team who will have mechanical engineers, computer science engineers who will be developing the engine control system or the ECU. There would be people who are actually working in materials who might end up doing the development of the engine mold, those kind of stuff. So, for each subsystem we can realize IPTs, and the earlier you can realize an IPT in the life cycle of the project development, the systems engineering, system product development, the more successful you will be. What are the objectives of typical IPTs? The IPT objectives involve, the first part is develop a design solution. That is our initial aim. Based on the requirements specified, who specifies the requirements? The requirements are always specified by the customer. So, the customer requirements are specified at some point of time, and the aim of the IPT is to develop a design solution, do a product or a systems engineering solution to meet the requirements of the customer. That is the first part. Then the second part of them is they should also be able to communicate this design solution. Communicate this design solution, when you are doing this communication, it should realize 3 things. The communication should be clear, so the customer should understand what the product or system design is all about. It should be effective, so that the person can visualize, understand how the needs or the requirements are being met, and it should be timely. For an example is that, let us say if you are talking about developing a mobile phone, or let us say somebody talks about developing a mobile phone that can be charged through Wi-Fi or through Bluetooth. That is currently one of the hot areas in the market. So, people are trying to find out how to charge the mobile phone through Wi-Fi signals or Bluetooth signals. In that process, if you come up and says that, okay, here I have developed a system which is bulky and it would require solar power and also a nuclear power plant to charge the mobile phone, it might not be a timely solution at that point. People might laugh at it because they think that, okay, there are much better solutions available. So, this is not so this is where a lot of the time many of the systems engineering or system development process fails, because the communication is not very timely. The competencies of an IPT or an integrated product teams, they are supposed to have quite a lot of competencies, and the first competency is about the systems engineering. This SE stands for systems engineering. Or in another way to think about it is, it's a technical management competency. The person should be able to manage the technical process or the technology process involved in it. So, you are doing a technological management. The second part is the IPT people should have competencies in the life cycle functions. The life cycle functions, there are 8 of them, and we will discuss what those 8 functions are later down the road. These people also should have technical specialities, or the IPT team should also have technical specialities. The technical specialities typically involve things like safety, risk, quality, those kind of things, etc. An example of this is like, let us say you are designing an airport or a runway. So, the person who is in charge of the safety, he or she should be able to specify the fire tender or the fire truck that is necessary, the time, speed, acceleration, quantity of water or form, whatever it is you want to call it. Okay. All these aspects, the person, this is part of the safety. So, the person should have knowledge on this if they are in the process of developing a airport system or airport runway or aprons or whatever it is, or the airport aircraft handling aspects of an airport. Similarly, quality person should be able to should know what are the ways in which quality can be enforced, like quality assurance and quality control, all these aspects they should also be able to do. So, these are called specialities. So, the team on the other hand, more than having knowledge about life cycle functions and the systems engineering or technical management, it is desirable to have technical speciality, risk and quality as part of the team capabilities. Also, the team should have some expertise in the business areas. The business areas typically involve budgeting, they should know how to do the budgeting, finance, contracting, etc. Contracting is an important aspect because many a times lot of the subcomponents of the system will actually be derived or described or developed by different people. So, the contracts or for to a large extent when we talk about subsystem or subcomponent development through multiple organizations, when you are having a scenario like this, when multiple organizations are involved, then a clear knowledge of the contracting is really necessary to realize to realize a complicated systems development. So, if the IPT, the integrated product teams have competencies in these 4 areas, then they will be able to do a much effective job of realizing a good product system development. So, as I told earlier, they should have competencies in the life cycle functions, and I also mentioned that there are 8 functions or 8 characteristic actions. So, these life cycle functions are characteristic actions that particularly relate to the life cycle of the system or the life of a system. So, the life cycle functions are we will go one by one because each one of them are important. So, the first one we will talk about is the life cycle function called the development, and the development function, it includes all activities necessary to evolve a system or a product from specified customer needs. So, the customer has specified some needs, the customer needs are specified to you already, and from there whatever you need to do, the activities that are necessary to evolve a system or a product from the customer needs is actually part of is called as a development aspect of the life, which is development function or the development aspect of the life cycle function. It can be a product or a process, a solution. So, can be a product or process solution. Okay. It can be a product or it can be a process, it matters, but at the end of the day the customer needs gets translated into a system or a product. Then we talk about the second life cycle function, which is called as the making, or there are many names available for this particular function. One of the common name is manufacturing. Some people call it as production, certain people call it as construction, etc. All these things comes out of making or realizing the product. Some people even call it as realizing the product or a process. Okay. So, not in different names, but the major aspects of this is the major activities covered under these are fabrication, of engineering models. That is one aspect of it. The engineering models are the initial models in which you are actually testing all the capabilities and fine tuning the design, final design. It is also the low rate initial production, your prototypes, beta prototypes, that has the functionalities, and you are basically testing them for further improvement and other aspects. Then we have is a full rate production of the system or product along with spares also. You just do not produce the product alone, you also need to produce its spares and things that are necessary to run the product. Then in cases if you are talking about a large scale system, and we talk about construction of it. The construction example you can think about it is an aircraft carrier. So if you talk about building an aircraft carrier like USS Enterprise or USS Nimitz, one of those large super carriers, then it is not just a manufacturing process, it is actually a construction. You are building one of its kind of an aircraft, but it is such a complex system, there are so many subsystems involved. So it would require, it will go through a complete life systems engineering process to realize that one product. So there will not be a large scale manufacturing. One of that type will probably be built. It can also be thought about it as building a large aircraft also, that is also possible. So anyway, all these aspects, the manufacturing, production, construction, whatever we mentioned about, in realizing the product of our process, which meets the needs that were specified in the development phase, is the second life cycle function of a product. The third life cycle function of a product is what we talk about it as a deployment, and deployment is also another common name. It is commonly known as fielding. This is not the fielding in cricket, but it is fielding the product realistically. And what is fielding or deployment? It is all activities towards delivering the product, transportation, logistics, assembly, then installation, then there is checkout, or like let us say training, housing. It is not the housing, but storing the product, or you can think about a storage, then all these functions etc. required to reach full operational capability. This is the deployment aspect of life cycle function. The third function of the life cycle, third aspect of the life cycle function, or third action of the life cycle functions. Now we will talk about the fourth aspect of the life cycle function, which is an operation. The fourth aspect is usually includes all activities necessary to achieve defined operational capabilities. It in under all operation environment. So if you think about it, an example, let's take an example of a field gun or artillery gun. This should be it should be able to do or deliver a projectile from a given point to a specified distance. So you might have a gun right here, and it should probably deliver the projectile to a given distance. So this distance is the d, okay, and the time of flight is t known to that, and here is when it's supposed to land. There is something called as a CEP, circular error probability, how accurate it will be. All those aspects will be part of that. So it should be able to do this whether it is in war time or peace time or rainy season, snow, it doesn't matter. Whatever be the operational environment, this system should be able to do or perform, deliver the task. The defined operational capabilities should be able to be delivered at whatever time period, whatever the situation is, whatever the operational environment is required. So this is the life cycle, third life cycle, fourth life cycle function called as the operational life cycle function of a product or a system. Then we talk about the fifth life cycle function, which is called as a support. And support is it's actually an interesting function because it involves all activities necessary to realize, to provide operational support. This involves stuff like logistics, maintenance, then it also involves management of materials or materials management. Okay, what we do here is that to realize these operations, whatever the capabilities that were specified in the product, to achieve that, what all support is necessary, that is part of, that is another function of a life cycle. So it will have logistics that are necessary, maintenance that is necessary, and material management is necessary. If you take about the field gun that we talk about it, it is transporting the field gun. So that is transportation of product, etc., is part of this. Maintenance is periodic maintenance, scheduled maintenance, unscheduled maintenance, all those kind of things as part of the maintenance. And management of materials will involve spares, and then what is also called as the projectiles, then gunpowder, all those aspects which are related to the field gun is another management of how do we manage these kind of things, how do we realize this. This is also one other aspect of the support. The sixth one is actually the disposal. Okay. So the disposal is, there are many names for this again. One common name that is used is decommissioning. Another name that it is also used for this is destruction, destroying. So either you are talking about decommissioning or destroying a particular product or a system, and it is to be done in such a way that it should meet all regulations, restrictions, and directives. So another one example of it is how the nuclear fuel disposal happens, or how do you decommission a big ship. In an example in India, people talk about the decommissioning of INS Vikrant, which is an aircraft carrier in India, and what are the things, care that was taken to ensure that the ship was decommissioned properly while meeting all regulations, restrictions, and directives. Some of these directives will be like something like environmental stuff, and then other agencies like pollution, etc., will also be part of this. The seventh life cycle function that we are going to talk about is called training, and the training, it is the all activities necessary to do what? To achieve and maintain know-how, achieve and maintain know-how, knowledge, to operate the system or to achieve full operational capabilities. This is the training aspect of it. It involves, it is the full operational capabilities in an efficient and effective manner. So, if we take about the example of the field artillery gun that we were discussing earlier, the efficiency is about being able to fire as quickly as possible with minimum amount of time, deliver the fire accurately at the given point, and the effectiveness is about inflicting the maximum damage with the minimum amount of projectiles or minimum amount of firing. So, both efficiency and effectiveness are aspects of the operational capabilities or achieving the operational capabilities. So, training is related to the manpower or the human resource that is involved in operating the system. That is the seventh life cycle function that we have discussed today. And then the last one is the verification, or the verification as the eighth life cycle function, and this involves all activities necessary to evaluate progress and effectiveness of the product. So here what we are talking about is how good or well the product development is going on, how good is the product performance. We also talk about how effective is the product. The effectiveness can be again something like a competition or other products which are similar products that are in the market. So, all these 8 aspects, the development, the making, the deployment, the operations, the support, the disposal, training and verification, all of these 8 of them, these 8 actions related to the system life cycle is also one important aspect of the life cycle function, because all these things together is also something that is the IPT, the integrated product team, needs to be capable of doing. They might not have expertise in everything, but they would probably be having expertise in parts of things. Some people might have their expertise in development and making. So, this could be one, maybe like a IPT 1 might take care of this. The deployment might be taken care of by IPT 2, which could be doing something else, whereas some of these aspects might be taken by another IPT, stuff like that. So, in a totality, the total teams, all the IPTs put together should be able to achieve all these 8. And if that is happens, then systems engineering process achieves full capability. So, summing up, as we discussed earlier, the 3 aspects we talk about: the development phasing, in which the system details, the baselines of the system are developed from here by applying the systems engineering process. So, against these baselines, then the life cycle, the integrated the integrated development of the system or the product happens with the help of life cycle planning and having an integrated teams. And all of these things together, put together, all these aspects put together, forms what we call as a central node of it, which is called as the systems engineering and management, or you can call it as systems engineering management also, SEM. So, we have seen the major functions of it, and over the time this whole 3 aspects, the development phasing, the systems engineering process, the life cycle integration, they have all undergone changes / revisions / modifications. Things have been changed, modified, improved. So, we will see some of what are the new changes, what are the new additions, what are the new upgradations that has happened in this basic process in the next classes to come. And in that process also we will realize what are the new tools and how the systems engineering process SEM also is a evolving process, evolving and improving process. With that, we will conclude today's lecture, and we will catch up with the upgradations to these things and new tools in the next classes to come. Thank you.